Alright guys, so we're going to take a look at some graphing right now. So we've got different formulas to use to graph. We've also got some aspects about those that we need to remember. Okay, so the thing that we need to remember is that we could have some discrete graphs as well as continuous. Okay, remember that discrete are things that don't really have the in-between spots. Okay, that basically we don't draw the line, we just have the dots, and it just, what we see there is what we've got. And generally when we're talking about discrete, we look for that sequence notation, because if it's a sequence, then it's going to be discrete, okay, because you're only going to have the numbers, not the in-between parts. Whereas with continuous, we will, okay. Now, if we have a story problem, it could take something that normally looks continuous and make it discrete, or vice versa, just kind of based on what you're dealing with. And with tables, generally, if it's in this sequence notation like that, that's when it would be discrete. And if that were the case, then we just grab the points, right? So remember, the first left side generally is the x. That's our x-axis, the horizontal. So I go to -1. That's my start. But then I have to graph the second variable with it, the y, the 6, which the y is the horizontal. And so it's going to go up, and our point's going to actually be right there. Okay, just kind of a quick reminder if you forgot how to graph. So when we have a table, it's like they're the points, right? 0, 3, 1, 0, 2, -3, and so on. So 0, 3 right here, that would be our start number, but when we deal with it as a graph, we call it our y-intercept. 1, 0 would be our x-intercept. Sometimes that can be important too. Then we've got 2, -3, and 3, -6. Okay, so if this were n and a sub n, we'd be done right there. Because that's a discrete function, we wouldn't need to draw the arrows to continue it, because what we see on the table is what we've got. But since it's x and y, we should really draw our line there, because that's generally, in those cases, it's generally continuous, and so you want to draw those lines because every single point here, right, is a solution. That was kind of the whole concept with continuous, is every point is a solution. It would keep going, so you draw the arrows to keep it going. All right, so try number 2 on your own first, then pause it now, try number 2 on your own, and then see how you did. So we'd go 0, 1, there's our y-intercept, 1, 2, 2, 3, this one's an easy pattern to see, 3, 4, and 4, 5. And again, being that it's xy, we can draw our line just like that. Okay. Now, 3 and 4 are in the recursive form, right? Which we see with that sequence notation as well, which tells us, okay, with this recursive form, these ones are going to be discrete. And then that a sub 0 equals 1, that's our start. In graphing, our start is the same thing as our y-intercept, isn't it? Where the x is 0 and the y is whatever it is. In this case, that 0 tells you that's like the x part, and this is the y part, so it would be 0, 1. So there's our y-intercept, there's our start. Then the growth is +2. Now some people will think that means you go to the right 2. Some will say you just go up 2. Others will say you go to the right and up 2, and that's your next point. But that's not how it works, because we have to remember with a sequence, okay, and kind of drawing a table can help us, is the idea that the a sub 0 equals 1, there's our 0 term. Now we want to know what's our first term. Well, we'd add 2 to that, so it'd be 3. Then we want to know our second term, so we'd add 2 to that and we'd get 5, and so on, right? That would be the pattern. So the term number, that's like the input, that's like the x. Okay, so I go to the right 1 for my first term, and we said that was 3. Then I go to the right 1 again, that's my second term, we said that was 5. And then 3 would be 7, which would be a little bit higher, right? Now, because it's recursive, we can just leave it like that. Now, we could recognize that, yeah, this is going to keep going, and maybe draw an arrow to show that it keeps going. But it's good enough to just do it that way. Okay. All right, again, pause it. Try number 4 on your own. So looking at number 4, we've got our a sub n equals a sub n minus 1 minus 3. So there's our growth. And then a sub 0 equals 4. So that's our start number, our y-intercept. So at 0, I go up to 4. Then as I go to the right one for my first term, we go down 3. So right there. As I go right one for my second term, I go down 3. So right here, and we can kind of see that pattern. We go to the next term and then down 3 again. And we've got it right there. Okay. All right, now 5 and 6 look similar to 3 and 4 in the fact that we have that sequence notation. Oh, well, at least on number 5. Number 6 we actually don't, do we? But we've also got the explicit form. Now, the way we've been talking about it is we've been going either y equals or a sub n equals, and then we did our start number, right? In this case, -4. Then we would add, subtract, multiply, or divide our growth times n. So sometimes they may write it the other way, and that's okay. The thing we have to pay attention to is remembering that our growth is the one with the variable. The start, or y-intercept, is the one that doesn't have the variable. So I'd start at -4. There's my y-intercept. Then we're adding 3. And again, because we're thinking about that sequence, it's like my next term is my first term. So I'm going to add 3. I'm going to go to the right to my first term, add 3 on the y value. I'm going to go to my second term, and then add 3 to that. My third term, add 3 to that, and so on. Okay? Because it's got that sequence notation, we don't draw the line. Whereas now in number 6, it's the same concept with the growth and the start. But because we have the y and the x, that generally means we're graphing a continuous function here. Relationship, I should say. That we have to draw the line now. Okay? That's kind of what it's getting at. But we still treat it the same. So we started at 2, 0, 2. We're subtracting 5. So as I go to the right one, I'm going to subtract 5. If I go to the right one, we'd subtract 5. Okay. And because it's got the y and the x, now we're going to make sure we draw our line. Because all those places are possible answers, solutions on that line. Okay? All right. So now all the rest of these are really more that slope-intercept form, right? Where now we've taken the starting and we put it last and we put the slope first. And that slope is another word for growth when we're dealing with graphing, okay? But we kind of think about it differently in terms of how we move horizontally, okay? And the way to think about it is that you're going to make a fraction, okay? So if there is no fraction, you turn it into a fraction. And the bottom number, just kind of like how we did it over here, we didn't make a fraction, but we moved to the right one, didn't we? For every next term. Well, it's like we put a 1 under there, kind of. Or same with here, we went down 5, but we moved to the right one and down 5 each time. Okay? It's kind of that same concept. We often hear it called rise over run. Okay? It's our slope, it's how it changes, how we go from one dot to the next. You also hear it saying delta y over delta x, change in y over change in x, the change in that vertical over the change in the horizontal, that y over x. So 4 would be our vertical change. Because it's positive, we go up, because positive is up. The 1, we'd go to the right, because it's positive, and positive on the x-axis is to the right. Okay? So we have our start number, our y-intercept. So at -2, start at -2 here. Then my slope tells me I'm going up 4 and to the right one. And you can say it either way, to the right one and up 4. When I do that, Okay. Now with these ones, we're doing kind of the same pattern, so I could go backwards on that pattern and go down 4 into the left one. And we see it's that same pattern, so we can draw our line. Just like that. Okay, try number 8, 9, and 10 on your own. Pause it, and then check to see how you did. All right, so number 8, we would add 1 to both sides. So add 1 to both sides. Well, we start at 1, because that's our y-intercept. There's no variable with it. Then we're going -3. So think of it as that fraction. So I go to the right for negative, and I go down 3. So to the right 1, down 3. To the right 1, down 3. Or going backwards to the left 1, up 3. Kind of like if we switch that negative to be with the 1, then we'd be going up and to the left. Which, as we notice, up 3 into the left 1 is still the same pattern. Okay, still the same pattern. Number 9, we'd start at +4, so up to 4. Slope of -5, think of it as -5 over 1 or 5 over -1. Okay, so I'm either going down and to the right or up and to the left, which is really the same thing. Doesn't make sense to go up 5 here, so I would probably just go down 5 to the right 1, down 5. And really you only need generally 3 points is enough to get a good sketch of your line. Okay, number 10, slope of 6, so that's like 6 over 1, that's up and to the right. Okay, we could also think of that as -6 over -1, which would be down and to the left, which is, again, the same exact thing. So start at -5. We could go down 6 into the left one, but that won't be as easy as going up 6 into the right one. Up 6, the right one. Again, that gives us our line. We connect the dots because in these situations, they're continuous, and so everything in between, everything either direction, works. Alrighty? Okay, now these last two problems, now they've given us the fraction, haven't they? Okay, so now what we want to do is, it's really the same thing, okay? So we look at our fraction, that's our growth because it's with the x, so 2 over 3. The 2 is a vertical change, positive, so going up. 3 is a horizontal change, positive, going to the right. We start at -4 for our y-intercept, so I go down to -4, and then I go up 2 to the right 3. There's my next point. Then continuing from that, up 2 to the right 3. And just like I was saying earlier, that could be a negative over a negative, and I could go down 2 and to the left 3. And see, it's still that same pattern. Okay? So try number 12 on your own, pause it, and hopefully you tried it on your own. Let's check your work. +5, so we start up here, our y-intercept of 5, -3 over 4. Now, some of you may kind of treat it this way and say, oh, it's a negative, so I go down and to the left. But it's not, because negative over a negative is like positive over a positive. Okay, because when you divide a negative by a negative, it makes it a positive. So you attach that negative to 1. Could be to the 3, or it could be to the 4. Doesn't matter, because if it's to the 3, it's down and to the right. If it's to the 4, it's up and to the left, which gives us the same result. So in this case, we're already up high, so I'd probably go down 3, to the right 4, down 3, to the right 4. Okay, and we get our line, and we are good to go. Okay, and that's just kind of the basics of graphing. So yeah, there we go. Generally, we see more like when we're graphing, it's more like this back side, less like the front. But I just wanted to make sure we knew how to do everything.